Hello everyone, this is the second video on the examples of recursion. Today we will learn to code Taylor series, Fibonacci series and the combination formula using recursion. Let's see what is Taylor series. The value of the exponential function can be calculated using the Taylor series as e to the power x is equals to 1 plus x by 1 factorial plus x squared by 2 factorial plus x cube by 3 factorial and so on up to n number of terms. As the number of terms increases, the precision of calculation of e to the power x also increases. Now we will build up an idea to generate the Taylor series by recursion. Let us declare a function, say Taylor, of return type double, and it should take two integer parameters x and n as the input. So double Taylor, and it should take the integer parameters x and int n. So this will be our function. This function should be called recursively up to n equals 0, and at the returning time the values x by 1 factorial, x by 2 factorial and x by 3 factorial, x cube by 3 factorial and so on will get added up. Let's say x is equals to 1, and so we need to compute the value of e to the power 1. Okay, and let's say we take the precision, we take the number of terms n as 4. So at first from the main function we will call Taylor 1 comma 4. Now then this will call recursively, this Taylor function will call Taylor 1 comma 3. Next it will call Taylor 1 comma 2. Next it will call Taylor 1 comma 1. Then it will call Taylor 1 comma 0. And now n is equals to 0 will be our breakpoint. When n is equals to 0, it should return the value 1. The value 1 will be returned to this function Taylor 1 comma 1, and then we will add x by 1 factorial, and this entire value, that is 1 plus, this is equals to 1 plus x by 1 factorial, this value will be returned back to the value this function Taylor 1 comma 2 call. And then we will add, with this function we will add x square by 2 factorial, and then this entire value, this will become 1 plus x by 1 factorial plus x square by 2 factorial. This value will be returned back to this call Taylor 1 comma 3, and then we will add x cube by 3 factorial with this value, and so it will become 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial. This entire value will be returned back to this call, and so this is our final output. So this is basically the idea and now to keep a track of the powers of x and the factorials, we need two variables. These variables may be static or they may be declared outside the Taylor function, which will be initialized to 1. That is, we will declare two variables p to keep the track of these powers of x, and another variable fact to calculate these factorials. Okay, and this value will be initialized to 1 at the first. Okay, and during the returning time at each step p will get multiplied with x and the factorial by the value of n, so that we can use the result p by factorial to get x by 1 factorial, x by x square by 2 factorial and so on. Okay, so at each step, so when Taylor 1 comma 0 returns 1, back to here, we will multiply p with p into x and factorial with factorial into n. Okay, and then we will use the value p by n, p by fact, so this will become x by 1 factorial. After that we will add and return that value. Okay, so this is the basic idea. So now let me just erase these parts so that I can write the function Taylor. Okay, okay, so inside this Taylor function we will first check the breakpoint, that is if here I have already told about the breakpoint, that is if n is equals to 0, that is if this value is equals to 0, then it should return 1. Now within the else part we will write these conditions, that first it will call the Taylor function recursively up to n equals to 0. Okay, and then we will perform all these tasks at the returning time of the recursion. So it will call the Taylor. So here we need a variable double r to store the return value. Okay, so here when Taylor 1 comma 0 will return the value 1, this 1 should be stored, and then this calculation will be performed, and then this entire value will be returned to its previous call. So we need a variable. Let's declare this variable as double r, which will store this return value, that is Taylor 1, this is will be equals to x n minus 1. Okay, so x will be decremented by 1 at each step. First x not, n will be decremented by 1 at each step. First n is equals to 4, then it will become 3, then 2 and 1, and finally 0. Next, the next step is p will be equals to p into equals to x. Okay, so I have already discussed about this, that p will be multiplied with x at each step, and the fact will get multiplied with n at each step, and next the return will be return r plus p by fact. Okay, so I have already discussed this, how we are getting this. So this is the entire Taylor series function. Now we will trace this and see whether we have written this code correctly or not. Okay, so now let's do the tracing part, and here let us take the value of x as s and n as 4. So let's see. So from the main function, the firstly it will call the Taylor function with Taylor with value x and n is equals to 4. Next, within the value r, Taylor r will be equals to Taylor x comma 3. Then this recursive function will get performed, and it will recursively call Taylor x comma 2. Then it will call Taylor x comma 1. Then it will call Taylor x comma 0. Now when n becomes 0, so it will return 1, thus this function will return 1. So at this stage r is equals to 1. Then after this call we will move to p. So initially we have p is equals to 1 and fact is equals to 1. Okay, now p will be equals to p into x, so p will become x at this point, and fact will be equals to, so n minus 1 is equals to 0, so at this stage fact will be equals to 1. Okay, so we will return r plus p by fact. So r is equals to 1 plus p is equals to x by 1 factorial, and this value will get returned to r is equals to Taylor x comma 1. Now with this, p is equals to p into equals to x, so p is x, so x into x will become x square, so and fact will equals to fact into equals to n, so n minus 1 is equals to 1 at this stage, so n will be equals to 2, so 1 into 2 will give 2 factorial 2, so this will be equals to 1 plus x by 1 factorial plus x square by 2 factorial. Now this will be returned back to this value r, and here we will again get x cube, and here we will get 1 into 2, that is 2 factorial, into 3, that is 3 factorial. So this will become x cube by 3 factorial, and this entire value will get returned to this value, this r, that is Taylor x comma 3, and then this here we will get x to the power 4 by 4 factorial, and this will be returned back by this call, that is Taylor x comma 4, and this will be printed at the end, that is this will get printed at the main function. Okay, so our tracing is correct. Now let's move to our IDE and code this Taylor function and see whether we get the correct output or not. Now moving on to this Visual Studio, we will here create a Taylor function that is should return double Taylor, and it should take two integer parameters as x and n. Now here we will declare the variables p and fact as static variables, so that these variables will be initialized only once. Okay, or we can declare these variables outside the Taylor function, that will also do. So let me just declare this variable outside this Taylor function as double a is equals to 1 and fact is equals to again 1. Okay, so basically I have taken the variable a in place of p, so that's not an issue. Now here we will check for the breakpoint first, that if n is equals to 0, then it should return 1, else uh, else declare a variable r, that is double r. Okay, and else within the variable r should store the return of the recursive call, that is r should be equals to x comma n minus 1, and uh, then a should be incremented by x and fact should be incremented by n, then we should return r plus a by fact. So this is our code. Now we will call it from the main function, and let's say within the main function we will call the function Taylor with, let's say for example we take x is equals to 1 and let's say n is equals to 8. Okay, so now let's run this program and see whether we get the correct output or not. Yes, so we have got 2.71828 as our output, and if we calculate the value of e to the power 1 using our calculator, we get the value as 2.71828, and something. So we got the correct answer, and this is how the Taylor this is how we can quote the Taylor series using recursion. Okay, so now let's quote our next problem, that is the Fibonacci series. So Fibonacci series is a sequence of integer that starts with 0 followed by 1. So Fibonacci series is somewhat like this, that is 0 and 1. It always starts with 0 and 1. The first two terms of the series are always fixed, that is 0 and 1, and the next terms are generated by summing up its preceding two terms. So let me say that we want to write a Fibonacci series where there are n terms, that is where there are 8 terms, let's say. So 0 and 1 will be fixed. Then the third term will be a sum of its the second term and the uh, first term, that is 0 plus 1. This will again be is equals to 1, and the fourth term will be the sum of these two terms, that is 1 plus 1, that is equals to 2. The fifth term will be the sum of its preceding two terms, that is 2 plus 1 is equals to 3, and the sixth term will be 2 plus 3 is equals to 4, and the seventh term will be 2 plus 3, that will be equals to 5, and the seventh term will be 5 plus 3, that is equals to 8, and the eighth term will be 8 plus 5, that is equals to 13. So this is how a Fibonacci series, this is a Fibonacci series, that is 0 1 1 2 3 5 8 and 13, where there are 8 terms in this series. In this way we can generate n number of terms of a Fibonacci series. Okay, so if we want to write this expression mathematically, that mathematical expression is, suppose f of n is, f is the Fibonacci series, and f of n is equals to f of n minus 1 plus f of n minus 2, where the base values, that is f of 0 is equals to 0 and f of 1 is equals to 1. So this is so we will use this idea to quote the Fibonacci series using recursion. So we will declare a function, of return type int, and let's say this function as Fibo, which and this function will be called recursively, and this will take one parameter, that is only int n. The breakpoints of the recursion are, that is if we come to the base values, then if n becomes 0 or n becomes 1, if n becomes 0 then it should return 0, and if n becomes 1 then it should return 1. So this is our breakpoint of recursion. So we will write first, if n is equals to 0, then return 0, else if n is equals to 1, then it should return 1, else in the else part. So we have completed the breakpoint, and in the else part we will just return the sum of the previous two terms, that is return Fibo of n minus 1 plus Fibo of n minus 2. So this is how we have implemented recursion to generate the function of Fibonacci series. Now inside the main function, int main, okay, we will take the value of n is the number of terms, we will take the value of n as input from the user, and we will run a loop, that is for int I is equals to 0, I less than n, I plus plus, and within this loop we will call the function Fibo. We will actually print the value that will be returned by the function Fibo with parameter as I. Now let's trace this function and see if we have coded this function correctly or not. So we have take n as 4, let's say. So at first the for loop I will, this for loop will run from 0 for I is equals to 0, 1, 2 and 3, because I is less than n, so it will run for 4 values. Now for I is equals to 1, for let's say for I is equals to 0, it will call fibo of 0. Now when fibo of 0 is called, that is n is equals to 0, so it will return 0, so the value 0 will get printed. Okay, next I will be incremented by 1 and I is equals to 1. Now fibo of 1 will be called and we will get 1 again, because if we have written here that if n is equals to 1, return 1. Now next we have call I is equals to 2. We the call will be fibo of 2. Okay, now fibo of 2 will return fibo of, now when fibo of 2 is called, here I am doing because okay, let's scroll down and fibo of 2, for fibo of 2 it will return fibo of n minus 1, that is 2 minus 1 is 1 plus something. This something will be called after this recursive function is executed. This will be executed after this function. Okay, so first fibo of 1 will get executed. Now fibo of 1, it should return 1. Okay, because n is equals to 1, when if n is equals to 1, then fibo of 1 should return 1. Okay, so this will return 1. Now after this has been returned, the next fibo of n minus 2, that is 2 minus 2, that is fibo of 0 will get called. Okay, now this will return 0 as we have seen previously. So 1 plus 0 will finally give me 1, and therefore fibo of 2 will return the value 1, and so 1 will get printed here. Next, when I is equals to 3, then for fibo of 3 will be executed, and fibo of 3, for fibo of 3 it will move up to this else part, and it will first call fibo of 3 minus 1, that is fibo of 2. So fibo of 2, as we have seen here, that fibo of 2 will call fibo of 1, and fibo of 1 will return 1. Then it will call fibo of 0, and fibo of 0 will return 0. So this fibo of 2 will return the value 1. When fibo of 2 will return the value 1, then fibo of 3 minus 2, that is fibo of 1 will get called, and fibo of 1 will return the value 1. Then 1 plus 1 will, fibo of 3 will return the value 2. So 2 will get printed. These are the 4 terms of the Fibonacci series that gets generated. So our tracing, so our code is all right because we got the correct tracing. Now let's move on to our IDE. Here we will write a function of return type int, that is int fibo, and it should take an integer value as parameter. Okay, then if n is equals to 0, then it should return 0, else if n is equals to 1, then it should return the value 1, else it should return the value fibo of n minus 1 plus fibo of n minus 2. Okay, now in the main function we will let's say we take the n is as 4, and here we will run a for loop for int I is equals to 0, that is I less than n, I plus plus, and inside here we will just simply print the returned value from the function fibo, that is fibo of, we will send I as the parameters. Okay, so let's run this program and see. Yes, so here we have got 0 1 1 2, that is exactly matching what we have traced. We will see how to code the combination formula using recursion. Now you must have studied in mathematics about the combination formula. That is, let's say we have NCR. This is how it is represented. Okay, this is equals to, this gives the formula for this is n factorial divided by r factorial into n minus r factorial. Now what is basically the combination? You must have studied mathematics about the permutation and combination problems. Okay, so combination, let's say we have A, B and C. Now how many ways we can permute these three alphabets in a group of two? So we can permute as AB, BC, BA and AC and CA and CB. So there are 6 ways we can permute these three alphabets, or we can arrange these three alphabets in a group of 2. Now this is, so the permutation is, that is 3p2, that is 3p2 will be equals to 6. So permutation actually means arrangement, and using combination, so how many, so the combination formula, that is 3c2 will actually give me the answer 3. Now in during combination we can only consider about the alphabets, about the grouping of the alphabets and not their order. That is A, B and BA will be considered same in combination, so we will treat these as 1. Now BC and CB will be considered same, so this will be treated as 1, and AC and CA will be considered same. So we are not concerned about the order, we are only concerned about the selection, so this will be again 1. So combination is equals to 3. So this is the basic idea about permutation combination, and this is very basic. And so NCR, the formula for NCR is equals to n factorial divided by r factorial into n minus r factorial. And there is one another formula which we can derive from Pascal's triangle, that is NCR is equals to n minus 1 CR minus 1 plus n minus 1 CR. Okay, now this formula is basically derived from Pascal's triangle. So basically this formula will help us to code the combination formula using recursion. So we will basically, declare a function, say combi, and the return type of this function will be integer, because NCR will always generate integer values, and inside, and this function will take two parameters, that is two integer parameters as int n and int r. Okay, now the breakpoint is, you must have learned in combination formula that nc0 is always equals to 1, and this is equals to also ncn. Okay, so basically the formula is ncr is equals to nc n minus r. So nc0 will be equals to nc n minus 0, that is n, and this always gives me 1. So this will be my breakpoint. So if r is equals to 0, and or r is equals to n, that is if r is equals to 0 or r is equals to n, then this should return me the value 1, because as we have seen here, the values are constant and is equals to 1. Else it should return the value, else this should return the value combi n minus 1 comma r minus 1 plus combi n minus 1 comma r. So that's all. We have coded this combination formula. Is very simple. Now let's trace this and see if we have coded this correctly. So inside the main function, let's say we have printed the value for com 3 comma 2. So this should print 3c2. This should basically print the value 3. Now let's see if we have if this code can generate the right output or not. So inside the tracing part, firstly this will call combi 3 comma 2 from the main function itself. Now if r is equals to 0 or r is equals to n, then this should return 1. So r is equals to 2, so it will go to the else part and it will call the function combi n minus 1 comma r minus 1. So n will become 3 minus 1, that it will become 2, and r minus 1 will become 1. Now plus something, we will go back to here once we have completed this function. Next r is equals to 1, so it will again return to the else part and it will call combi 2 minus 1, that is 1, and 1 minus 1, that is 0. Now plus something, now we will return back here once this function has been executed. So r is 0 here, so this will return the value 1. Now this will return to its previous call and it will execute this part, that then it will call combi n minus 1, that is 1, and 1. Okay, now here r is equals to 1 and n is also equals to 1. So we have, so this condition is true, that is r is equals to n, then this should again return the value 1. Then 1 plus 1 is equals to 2, and then the control will move to its previous call with this value. Okay, so this combi 2 comma 1 will be equals to 2. Now once this function has been executed, then it will move to this call and it will call combi 2 comma 2. Now again r is equals to n, so this value will be 1. Okay, so 2 plus 1 is equals to 3 and it will return to its previous call with this value. So combi 3 comma 2 is equals to 3. So finally the value 3 will get printed, and mathematically we have also seen that 3c2 is equals to 3. So our code is all right. Now let's move on to our IDE. Now here we will declare a new function of integer return type, that is combi, and it will take two parameters, that's int n and int r. And inside this function, if n is equals to if r is equals to n, or r is equals to 0, then it should return 1. And else it should return combi n minus 1 comma r minus 1 plus combi n minus 1 comma r. Now from the main function we will erase this part and we will print the value of count combi 3 comma 2. Okay, now let's run this program and see if we get the right output or not. Yes, we have got the answer 3, so this is our right output. in the next video we will try to quote the Tower of Hanoi problem, and it is a very interesting one. So if you really find these videos helpful, then please like, share and subscribe to our channel.